Dr. Vijay Lakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE-sponsored MODROB project for VLSI Lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing cent percentage of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series, BSc Electronics Honors, practical session, MATLAB programming. In today's episode, we will discuss about convolution of signals. So, convolution is nothing but generating the third signal by using the two signals with the help of mathematical representation. So, we have a more number of methods to generate the convolution signal, but here we will discuss only two. One is linear convolution, another one is circular convolution. Linear convolution is the basic operation to calculate the output for any linear time invariant system given to its input and its impulse response. That is impulse response system H of n. So, I am giving the input signal x of n, I am getting output y of n. This is a convolution. So, how we are representing y of n is equal to h of n convolution with, this is a symbol for convolution, convolution with x of n. That is, output is depends on the system response based on the input signal, right. Y of n is equal to h of n into x of n convolution with h of n. Circular convolution is the same thing, but considering that support of signal is periodic. Here also we are giving the x of n input signal to the impulse system, which is our linear time invariant system h of n, we are getting the output y of n, but the x of n signal is periodic signal. So, again I define the convolution. Convolution is the mathematical process that relates the output signal y of t of a linear time invariant system to its input signal x of t and impulse response h of t. So, y of t is equal to x of t convolution with h of t. If the signal is continuous signal, then we are representing it as a t. Its convolution response is represented with y of t is equal to integral of minus infinite to plus infinite x of tau into h of t minus tau with respect to d tau. This is a formula for continuous signal. So, we will discuss linear convolution. This is for discrete signal. Y of n equal to summation of k equal to minus infinite to plus infinite h of k x of n minus k, right. Suppose we have a finite signal, then you can write it as k equal to 0 to n h of k into x of n minus k. In the linear convolution, we have two signals x of n and h of n, right, both having two different lengths. Suppose h of n is equal to n, x of n equal to m, then we need to generate y of n, which is a different length L. So, how we are calculating L? L is equal to m plus n minus 1. The sum of two sequences minus 1, that will define the length of output signal. I will explain how to generate the linear convolution signal. So, y of n is equal to summation of k equal to 0 to L minus 1, I take it. Then here x of k h of n minus k, right. Now, we have to substitute the value. How we are finding L value? L is equal to m plus n minus 1. M is the length of x of n is the length of h of n. Okay. Now, substitute n equal to 0, what do you get? Y of 0 is equal to summation of k equal to 0 to L minus 1 x of k into h of minus k. Then expand this summation to 0 to L, that is x of 0 h of minus 0, then x of 1 h of minus 1, like that you have to develop. But here we are planning to write the coding only, so it automatically generate. So, y of 1 is equal to summation of k equal to 0 to L minus 1 x of k into h of 1 minus k. So, actually we have a x of k signal. How to generate h of k signal means, which based on the folding. Folding means with respect to 0. Suppose I have a h of k value as 1 2 1, right. So, it may be represented like this. So, this is point at 0. So, 0 1 2. So, 0 amplitude magnitude value is 1, 1 magnitude value is 2, then 2 magnitude value is 1, remaining values are 0 0. How to generate h of minus k means, with respect to 0 we have to fold the signal, that is with 0 the magnitude value is 1, for 1 it become minus 1, for 2 value it become minus 2. Okay. So, these two signals are come to this side, the right hand side signal become left hand side. This is a processing of h of generating h of minus k, this is named it as folding. Suppose if you want to, now the x of k original signal should be multiplied with h of 1 minus k. So, how to generate h of 1 minus k means, just you delay the signal minus 2 minus 1 0 1 2, right. Now, the signal is delayed by 1. So, here the magnitude value is 1, in 0 the magnitude value is 2, for 1 the magnitude value is 1. For n equal to 2 you have to find y of 2. Y of 2 is equal to summation of k equal to 0 to L minus 1 x of k h of 2 minus k. Okay. So, one more shift, that is minus 2 minus 1 0 1 2, right. So, here for 0 it is the value was 1, for 1 the value was 2, for 2 the value was 1. So, this is a way we are generating till the length of y of n sequence. So, here I have written the program for the summation. Okay. So, I just expand this one, suppose L equal to 3, suppose I have taken L equal to 3, then I have to find y of n is equal to summation of k equal to 0 to 3 minus 1 2 x of k h of n minus k, right. Suppose n equal to 0, y of 0 equal to summation of k equal to 0 to 2 x of k into h of minus k. Now, expand this. So, x of 0 h of minus 0 plus summation is written as plus x of 1 h of minus 1 plus x of 2 h of minus 2. So, this way. So, this value to be added with that next value, then added with this value. So, I have initialized this for S of n, that is one accumulator is initialized. So, first I will generate the multiplication of x of 0 into h of 0, then that value is stored in that, then again I do the multiplication and added with this and again multiplying these two values, then added. So, this is way I have developed the programming. Suppose if we are putting n equal to 1, then y of 1 is equal to summation of k equal to 0 to 2 x of k into h of minus k, right. So, how we will write it is x of 0 h of 1 minus k, 1 minus 0 is 1 plus x of 1 h of 1 minus 1 0 plus x of 2 equal to h of 1 minus 2 minus 1. So, this is a way we have to expand it and find the convolution of input signal with impulse signals. So, I will show one more signal which is the convolution of the signals. You may consider this as x of n, this is a h of n. So, h of n signal is 1 1 remaining as 0. So, 1 1 0 0. X of n value is 4 values, x of 0 value is 1, x of 1 value is 3, x of 2 value is minus 2, x of 3 value is plus 1. So, instead of y of n they have given us g. So, for 0 we are using this kind of representation. This is a way to find the corresponding multiplication and generating the result. So, now we will develop the MATLAB coding for linear convolution. So, select the edit window. So, first I will get the input sequence x equal to input. I ask the input. So, based on your length you can enter the value. So, enter the sequence. So, now I am reading its length. So, I assign with n1 equal to length of x. So, if suppose if we are giving 4 numbers, then n1 equal to 4. If we are giving 8 sequence 8 numbers, then n1 become 8. So, this is a way we are calling the number of sequence as length. Then I am getting the impulse signal h of n equal to input of within the single quote enter another sequence. Now, get its length as n2. So, n2 equal to length of h. Okay. So, now I have to calculate the total value, that is L. So, instead of L I give it as n, or you may give L also, right. So, L equal to, so it is L looks like 1, right. So, I take it as T. T equal to n1 plus n2 minus 1, right, that is m plus n minus 1. Now, I initialize the value x equal to within the square bracket x comma, that is I put all the x values, remaining values should be 0, right. So, I initialize remaining values as 0, zeros of 1 comma the length based on that 1 comma t minus n1. Okay. Then I initialize the x value x equal to square bracket x h comma, that is I want only that value, remaining values as 0 like seen in the diagram. Zeros of 1 comma t minus n2, the corresponding length. So, now I will start the program. First I want to vary the y of n value, then I want to expand the summation value. So, for y I declare this value for n equal to 1 to t, right. Then I initialize the accumulator value as 0. Then I am rotating the interloop, which is for expanding the summation for m equal to 1 to t, 1 to t I expand it. Then I write the formula p is equal to n minus m plus 1. If p value is less than or equal to 0, then you put p equal to p plus t. then end the loop. Now we have to do the multiplication process, that is S of n equal to S of n plus x of m multiplied with h of p. Okay. So, the p value is generated based on this m value. So, based on the two loops, I have a convolution, do the convolute with this formula, then end this, one more end for the loop. Okay. So, now stem of, you can give S or S of n. If you want to give the label, then give it as label x label as time period, then y label of amplitude. Then if you want to, if you give the title, now save the program as example 8. Now using this run button, run the program. Now it asks the sequence, right. So give 2 1 2 1, its length is 4, then I have to give the sequence h of n 1 2 1, its length is 3. So this is the output. Suppose if you want to generate the another value, so just note the value, x of n value is 1 3 minus 2 1, these two as 0, right. We will check this answer. Save this program, execute it, it will ask the value 1 3 minus 2 then 1, close it, its length is 4, then x of n value was, you can instead of giving 1 0 0, you give it only 1 1. So its length is 2, automatically it generate the value. How many values we are expecting? That is L equal to m plus n minus 1. So 4 plus 2 6 minus 1 5 samples. So 1 2 3 4 5. So the output value is 1 4 1 minus 1 1, right. So 1, for 0 its value is 1, 4 then 1 then minus 1 then 1. So this is a way to generate the convolution program. Execute the program for circular convolution. First get the input, enter the sequence. Then assign its length as n1, n1 equal to length of x. Then get the impulse signal h, enter impulse sequence. Then assign its length as n2, n2 equal to length of h. Thank you, sir. This is a circular convolution, so we have to take which length is maximum. So I will take it as n, which is the maximum of n1 comma n2. So either the input sequence or the impulse sequence, which one is maximum, it will take it as a length. Now I will assign the value t equal to n1 minus n2. If t less than 0, x equal to x comma zeros of 1 comma minus t, else h equal to h comma zeros of 1 comma t. Okay. This is for equating length. Then for n equal to 1 to capital N, assign the initial value like accumulator equal to 0 for m equal to 1 to capital N, p equal to n minus m plus 1. If p less than or equal to 0, p is assigned with p plus n. And now call all the values and add s of n equal to s of n plus x of m multiplied with h of p. End, end, two for loops are end. Now get the figure. For a discrete representation, we give it a stem of s. Axis you can assign with a 0 to 4. Then give x label, time period, y label, amplitude. Title, give it as circular convolution. The red color represents we are not completing with a proper format. So, after giving the quotation it will come to the normal one. Okay. So, now you save this example 14. Now execute it. So, after executing it will ask the sequence which are 2 comma 1 comma 2 comma 4. Then it asks the another sequence, you give it as 1 2 3 4. So, the error is capital M, right. So, change the capital M. Here also you can give it as capital M. Save the changes and run the program. So, it will ask the number 2 1 2 4, then you give it as 1 2 3 4. After typing that it will show the number capital N value, the length is assigned which one is maximum, right. Suppose I have given a different length, then it will shows the different answer. So, one value was 20, another value was 2, that is 2 having the 25, 3 having 26 nearer that value, right. So, we will verify in the practicals. Suppose if I give a different length. You can take the axis up to 10. So, save the program and execute it. So, now it asks the enter the sequence, right. I will give it as 1, 2, 3, okay, different length. This length is 3, then another length is I will give it as 1, 2, 3, 4, 5, okay. So, now we are expecting in the n which is the maximum, right. So, it automatically take n as 5, then it will generate the 5 samples. So, these are the values, right. Summary: in today's session we have discussed about what is convolution, what are the methods in the convolution, then how to develop the MATLAB coding. Questions: find the length of y of n when x of n equal to 1, 2, 3, 4, 5 and 6, and h of n equal to 2, 3, minus 1, 4. Write the convolution formula for discrete signal. What is the difference between linear and circular convolution? So, with this I wind this session. Thank you.